Hello, students. Let's start with something you've all come across, the cool mist of a room air conditioner or the sharp smell of cleaning solvents. Behind these everyday experiences are a group of chemicals called polyhalogen compounds. And LT, break time is equal to 0.5 SNGT. These are compounds that contain more than one halogen atom in their molecules. They are widely used as solvents, refrigerants, insecticides, and even in medicines. But here's the twist. The very properties that make them useful also make them dangerous because they tend to persist in the environment and accumulate in living organisms. And LT, break time is equal to 0.5 SNGT. So while they represent the brilliance of chemistry, they also remind us of its responsibility.
One common example is dichloromethane, or methylene chloride. It is a colorless, volatile liquid with a sweet smell. You may find it in paint removers, metal cleaning processes, or even as a solvent in drug manufacture. But high exposure can cause dizziness, nausea, and blurred vision. Direct skin contact can burn, and inhalation can depress the nervous system. So while dichloromethane is an important industrial solvent, it must be handled with great care. Its formula is CH2Cl2, and it is a perfect example of the dual nature of chemistry, both useful and hazardous. Now, let's talk about chloroform, also known as trichloromethane. Chloroform is used as a solvent for fats and alkaloids, and also in the production of refrigerant R22. Historically, it was even used as an anesthetic, but today it is no longer used because of its toxicity. Inhalation of chloroform can cause dizziness, fatigue, and even liver or kidney damage. Chemically, chloroform is unstable in air and light. It reacts slowly with oxygen. The reaction is CHCl 3 plus 1 by 2. O2 gives COCl 2 plus HCl. The product formed, phosgene COCl2, is a highly poisonous gas. That's why chloroform is always stored in dark, airtight bottles to prevent oxidation and the dangerous buildup of phosgene. Now let's talk about iodoform or triiodomethane. You may have seen its yellow crystals with a strong medicinal smell. It was once widely used as an antiseptic because it liberates free iodine, but it has now been replaced by more effective iodine preparations. Still, iodoform remains important in organic chemistry for its diagnostic role, the iodoform test. When a compound containing a COCH3 group or a CH2OH group next to a carbonyl is treated with iodine and sodium hydroxide, it gives a yellow precipitate of CHI3. This yellow solid is iodoform, and the test is a reliable way to identify methyl ketones. So, although its direct medical use has declined, its role in the lab continues. Next is carbon tetrachloride, or CCl4. Once upon a time, it was a household name in fire extinguishers and cleaning products. It is a colorless liquid with excellent solvent properties. But it turned out to be highly toxic, damaging the liver, nerves, and even the heart when inhaled or absorbed. Worse still, when released into the atmosphere, it reaches the stratosphere and contributes to ozone depletion. Because of this, its use has been restricted worldwide. This story of carbon tetrachloride is a lesson in how a wonder chemical can become an environmental villain. Among the most famous polyhalogen compounds are freons and DDT. Freons, or chlorofluorocarbons, were once the favorite refrigerants and aerosol propellants. For example, Freon 12 with formula CCl2F2 can be prepared from carbon tetrachloride and hydrogen fluoride. These compounds are stable, inert, and effective, but they diffuse into the upper atmosphere and destroy the ozone layer. DDT, or dichlorodiphenyltrichloroethane, was celebrated as a miracle insecticide, even earning a Nobel Prize for Paul Muller in 1948. But it turned into one of the greatest environmental controversies as DDT persists in soil and water, enters the food chain, and accumulates in animal tissues. It was banned in many countries after its devastating impact on birds, fish, and even human health was revealed. These two examples show how chemistry can solve problems, but also create new ones if not used responsibly. So let's wrap up. Polyhalogen compounds include dichloromethane, chloroform, iodoform, carbon tetrachloride, freons, and DDT. They have found uses as solvents, refrigerants, anesthetics, antiseptics, and insecticides. But their toxic effects, from nervous system depression to liver and kidney damage, and their environmental hazards such as ozone depletion and bioaccumulation, cannot be ignored. The big lesson here is balance. Chemistry gives us powerful tools, but we must understand and respect their consequences. Every compound has two faces, utility and risk. It is up to us, as chemists and citizens, to make choices that keep both human health and the planet safe. I hope this discussion made you see the importance of connecting chemistry with responsibility. See you next time with another fascinating exploration of the chemical world.